So if we're given a probability mass function, one of the most important things is how do we get useful information out of it? And what do we mean by useful information? So I've written here an example of a probability mass function. So I've listed the table and I've drawn a picture of the bar graph. And the question I want to know is, as an example of useful information, what is the most likely outcome for X, right? That, I think, is a very useful piece of information whenever you're dealing with a probability experiment, right? Which outcome should I expect to see most often, and how should I interpret that? Should you average the X values, right? Which outcome should happen the most? Well, I'll just take the average of all the different X values and see what I get. And I would say no, because if you were to do that, you're missing the most important piece of information, that all of those outcomes X are weighted by a probability. So instead of using a regular arithmetic average, we should use a weighted average. And what weights should we use? We are going to take the outcomes for X and we are going to weight them by the probabilities. And if you think about it, this seems reasonable. The probability is a number that tells us how likely it is that something will happen. So if an outcome has a higher probability, we think it should get more emphasis. So for instance, in this probability mass function, the outcome 1 is the most likely outcome to occur. So we think it should get increased emphasis. And at the same time, the outcome 5 is the least likely outcome to occur. So we think it should be de-emphasized. So what that means is we are going to define something called the expectation, or the expected value of a probability mass function. And we are going to define the expectation by this symbol mu, and it's going to be the sum of the values of X weighted by the probabilities. And so in a long form, that would mean, okay, you take the first value of X and you weight it by the first probability. You take the second value of X and you weight it by the second one, all the way down to the last value of X weighted by the last. So in our particular example here, if we wanted to know the expected or the expectation of this mass function, we would take the individual outcomes. So for instance, we would go, let's sum this where I starts at 0 and goes up to 5 of all of these xi's, p of xi. So the first outcome is that there is a 0, and that should be weighted by the probability, 0.06. Next, the outcome 1 should be weighted by the probability 0.42. The outcome 2 should be weighted by its probability, so on and so forth. And if we keep going and we tabulate everything in this way, we will end up with a calculation. And you can just take your calculator and hammer out this number, and you'll get up to a 1.97. Now you might say, well, how am I supposed to get 1.97? This is not one of the outcomes from X. We should think of this as a long-run average. If we were to repeat the experiment that generated this mass function, if we were to repeat it over and over and over and over again, we would find that if we were to keep track of the most likely outcome, what we would see is that on average, it would be 1.97. Okay? So this would be what we would get if we were to repeat the experiment over many times. And then if we were to keep track of the most likely outcome and average it in that sense, it will never be one of the given pieces of information. The expected value is where you would have to put a pivot on a teeter-totter in order for this thing to stay flat against gravity. So that's another useful way of thinking of this expected value. So the expectation is an important quantity that we will always want to extract from any experiment that we do.